Welcome back with another nice video. Today's topic is brazing process. It is coming under the category of welding and joining. That welding and joining is coming again under the category of manufacturing process. It's for mechanical engineering most commonly. This will be the last topic of the welding and joining. Right. Let us get inside and we will discuss. Before that, please watch the introduction clip, that image I have placed. There is three things you can see: a flame which is came from torch, and second there is a filler metal the guy is holding. Third, you can see some material metal, he is doing rework. Most probably it's a hollow tube. Color itself, we can easily identify this may be an color itself we can tell that it's an copper. Okay, so most probably you will get an idea by seeing these slides itself what is meant by brazing process and what is the best suitable material for brazing process, the category of repairing work. Right, now brazing is nothing but joining of two materials. We have to heat the metal, then again we have to melt the filler metal, then we are just going for joining process. So in the very beginning I have told autogeneous, homogeneous and heterogeneous welding category. If you carefully seeing this, we are adding third element to the material, so it is heterogeneous weld. Filler metal's temperature is 400 degree, that is the maximum. Kindly note this temperature level, because this is a main difference between soldering and brazing. Right, so what are the materials that we can join? Means aluminum, silver, copper, gold, nickel. And not only these materials, we can also do some dissimilar joints by using this copper filler metal. So what about the joint strength? That's a question which will arise in our head if you are talking about joints and other things. Most probably strength is so good up to certain level. We will see there is a small graph we have. After seeing the graph, we will get an idea. Okay, my students, please go through this additional reading. These are all the latest technologies in connection with brazing. Kindly take the textbooks and go through this topic. Since this is in 5 minutes clips, so I will not go through these special topics, only I will take care of the brazing process. Let us see this image again. I'm telling, he is using one filler metal, he is using flame and he is melting the filler metal to deposit over the base material to make the joint or doing repair work. If you are unable to see it in the first figure, let us see the schematic diagram. Welding torch, flame is available. Again I'm telling, most of the time we are going for repairing work for copper tubes. These type of copper tubes most probably you will see in the air conditioning unit. This is the best application, that is repairing work in the copper tube which is used in air conditioning unit will be the best application for brazing process. Again another one, if we have a mass productions, what we will do, generally we will take the metals or parts that to be brazed, we will place here and we will put the filler metal here, then it will be passed in the conveyor. Next stage it will reach the furnace. In furnace we are going to generate the heat. Right, with respect to the heat and the filler metal temperature, we are going to supply and control it. After that, what will happen inside the furnace, it will be the filler metal will be melt and they will make a small deposit layer over on it. If you see the output, you can see. Kindly note this symbol because this will give the difference between welding and brazing. Right, I told you this careful design of joint will give maximum strength. Right, up to how much? As you can see, the thickness of the joint is inches. it is reaching up to certain level. After that it is decreasing. That means up to certain level this filler metal, they will act as a unique material with respect to the base metal, so that strength will be over. If you are giving excess deposit, it will act as a third metal or second material which is so different than the base metal. Because of this combination, slight strength reductions will be appeared over the joint. And you see another figure how the joints will be represented, how it looks like. You can see there is two pieces are jointed here, 1 and 2 are butt jointed. The contacting surface of the bracing will be looks like this. Due to the capillary action, you may take that word, that also play a major role for this joining process. Again, the lap joint, the surface which is going to make a joint is shown in the cross section, dotted points or something different contours we have shown. The difference between weld and bracing, as you see, weld it will go to penetrate the base metal and make the joint, but in brace it will not penetrate the base metal, because maximum temperature of bracing is 450 degrees Celsius only, and we are using copper rod most of the time. But in welding we can't say the temperature is going more than 4000 degrees Celsius depending upon the welding process. Some welding process it may go around 3 times of the 4000 degrees Celsius and other things. If you are going for laser, sometimes it will evaporate the materials. Yes, think about the temperature and heat input. And next one, brace joints. Previous surgery we have seen, and this one does explain what is the basic difference between brace joints and weld joint. Brace joint, did you see any extra projection? No, smooth finishing is appeared. And in the weld joints, as you can see, different layers are available. Typically it's a multi-pass weld, right? So because of that only it appeared. Let us go to next slide, you will get another idea. General weld bead profile. If you're taking any welding operations, the workpiece will be appear like this. 3 regions will be available. Let me go through quickly. First one is the fusion zone at the center of the welding portion. Second one is the heat apparatus zone. It is just far away from the fusion zone, little bit, not that much, only 2 mm 3 mm far away from the weld zone, fusion zone. So the temperature received by the heat apparatus zone is very less, so it will not affect that much. Okay, another one is the unaffected base metal. Three things you can easily identify in the weld joints, but in bracing you can't. You are not believing my word? Just go to the next slides. These are all the research articles and some examples that I have taken from the web source. It will be very helpful for you. As I told before, there is one is fusion zone, second is heat apparatus zone. You can see something different over here, and is a unaffected base metal. And see the surface bead, previously we have seen something different one. Here you can see the surface bead, how it looks like, right? And the cross section of the weld portions over here, fusion zone, heat apparatus zone, and this is the unaffected base metal. But here, did you able to find out any heat apparatus zone or fusion zone over here? No, only the filler metal is melt and it filled the gap. Similarly, you look, this is a copper filler metal. Assume that is in golden color, so I am taking there's a copper filler metal. It's a workpiece 1, workpiece 2 that has been joined through bracing by melting the copper portion. You can see. Are you able to find out any heat apparatus zone? No, most probably no.